I'm going to bring up Vinny, who last week did an amazing job with the inspections. He's going to follow up and complete the inspection portion of the job. This is basically boiler room inspections. So I'm going to take a few minute breather, and Vinny will come in and do the inspection part of it.
So we're going to move ahead. This is over last time, and we're going to pick up on gas-fired units. Remember, these are the checklists that the inspectors are going through when they come in and they do our boiler inspections after everything's all done. All right, so I want you guys to be aware of what they're looking for. The gas-fired units only, gas piping material. What are they looking at? They're looking at the piping, the elbows. Make sure it's what? On gas pipe. I heard somebody say black. Black malleable, very good. Why don't we use cast iron? Why can't we use cast iron on gas? Come on, pipe fitters. Why? It's very porous. And what happens with porous fittings? It leaks. It leaks. Very good. Everybody knows the difference between the cast iron and the black, right? Cast iron is always a little heavier. Looks beefier, all right? If you don't know the difference, ask your foreman. Let him show you two pieces. Even the electricians should be able to know the difference between cast iron and black. Because if you see a mistake that somebody might have overlooked, you just saved the day. All right? So everybody should be aware of that. Gas piping and supports. They're looking at the hangers. Very important. You know, when we lock up the 3/8 nuts and bolts so that the hanger is right up on the pipe and holding the weight instead of it hanging loose. You know, sometimes we miss that. Sometimes the hanger pulls out because somebody pulled on the pipe. We got to fix that before we leave because they will give us a violation if there isn't enough hangers along that span. Normally on a gas piping, we're looking for every 8 feet, right, Dan? Every 8 feet, okay. So gas piping supports is important. Kindorf, whether it be clevis hangers, you know, they just want to make sure that the piping is properly supported. Gas shutoff valves. They're looking at the valves, make sure they're actually gas made for gas. Okay? It's important. It has to be the stuff, the equipment or the material manufactured for that usage. Because when something gets UL listed, it gets tested for what's intended to be used for. Okay? That's what they're looking at. They want to make sure that we're using the right products for what's its intention for it to be used for. Location to windows and doors. That's for the gas-fired units. Okay? They want to make sure that it's within working distance and it's clearing egress around the door. So if you have a boiler, all of a sudden you walk into a boiler room and you open a door and you can't open it all the way because the boiler's in the way. First off, it's swinging the wrong direction, right? So they're going to gig you on that. But if you open the door and you got to shimmy around it, they want to make sure they got enough clearances, all right? This is for gas piping too. Location and windows and doors. Make sure that the piping isn't in the way of the doors so that it doesn't open up. You know, if you open the door into a hallway, your pipe isn't in the way now. Over public sidewalks. Gas piping over public sidewalks is an issue there. Okay, can't have over public sidewalks, live gas lines. Height over a walk-in drive is a required height they're looking for on gas piping. Okay, it's got to be up above. Okay, I'm sorry. Danny just reminded me. This is all about gas vents. All right, they're looking at the vents for the regulators. All right, so the location near the windows and the doors, 18 inches away. Danny's got a slide on that. He's going to go over it. Over the public sidewalks, that the vents aren't in the way. The height over that, it's got to be up above the snow level and stuff. Height over the ground, same thing. And exposed vent length. Okay, that's the length of the vent piping. It's exposed. The vent length, they want to make sure it's the right size for the length. The longer we run a piece of pipe, the bigger that pipe has to get. All right, there's a chart that Con Edison has that we'll go over. But these are the stuff they're looking at, all right? And they're looking at the sizes of the piping. All right, that's on gas. Okay, next, oil-fired units only. They're looking at oil piping. All right? Same thing. Make sure it's supported. Okay? Just exactly like the gas. The material and size. Same thing. The black malleable, right? Can't use cast iron on oil lines. Protection. Make sure it's not in the way of a car hitting it, like in garages, right? Make sure it's protected from normal damage. All right, a lot of times we run the oil lines, the vents, and the fills through garages. We want to make sure that it's high enough that it's not going to get interrupted or broken. The valves. Make sure that the valves are in the right spot. Make sure that they have valves on the line where they're required. Above the oil tank, first thing is a valve. Then an anti-siphon, right? We went over it last month. Sometimes I've gone to jobs where we had the anti-siphon and the valve. It's a no-no. The valve's got to go first, between the tank and the anti-siphon valve. Okay? So that's what they're looking at. Preheater, we're coming away from that. On a 6 and 4 oil, there were always preheaters. But because 6 and 4 oil is going away, you're going to see a lot less of. You'll still see them, the preheaters, right? On the jobs that were taken out. We all know what they look like. The big side-on preheaters that are on the side of the boiler that actually circulates the hot water through that preheater to heat the oil up. And then you have an electric one that's on the burner. Okay? Any questions on any of this, guys? Gas or oil piping? Donald?
I've seen checklists, but I haven't seen the gas set up on the regular check.
I'm sorry?
I've seen check sheets already, but I haven't seen those on the regular check sheet.
On the regular, this is the bottom section of the check sheet. The normal checklist. The normal checklist, what we went over, or we started going over, we went over the top section. Go ahead. Okay. It's not as part of that? Okay. All right. So we'll get you the proper checklist, all right? So that you can go over. If you're not going through it, then, or if you don't see all of this, then we want to know about that. All right. Any other questions? I have a quick question. On the gas, what color do we normally paint it? Yellow. Oil, what color is the oil? Red. They're looking at that too. Okay? They want to make sure that it's all the same color. Or the right colors. Okay, let's move on. Oil tank rooms. Alright? In the oil tank rooms, we all know what they look like. Right? It's just a block wall with a door, containment in case the oil could spills. Right? Everybody knows what the oil tank room is? Alright. Walls and ceilings. Very simple. Walls and ceilings have to be blocked up. It's a fire-rated room. Fire-rated means fire can't get in, fire can't get out. Alright? It's a 3-hour fire-rated room. If I have holes in the ceiling or if I have holes in the walls, what happens to the fire? It can pass through that hole, right? So we want to make sure if you have it in an oil tank room and you see a hole in a corner, a little hole in a corner, just bring it to somebody's attention. What we're going to do is just patch it up, put a piece of steel over it, close it up so that it's sealed. The door construction. Remember, 3-hour fire-rated room. That door has to be made of steel, and it has to have a fire rating on it. If it's a wood door, is it a fire-rated door? No, of course not, because wood burns real fast, right? The steel is going to have a 3-hour rating, so if the fire gets up to that door, it's got to burn for at least 3 hours before it can penetrate that door, okay? The door is self-closing. Very simple. It just has spring-loaded hinges on it, right? So that if you open the door and you let it go, it has to close on its own. so to maintain that fire rating. Reason for that is if somebody leaves the door open and walks away, now I lose my fire rating, right? Same thing with the boiler room doors. It's very, very important that that door closes as people pass through, all right? And open out, all right? Just a quick thing, because this is a pet peeve of mine. When we go into the boiler rooms, right, and we're going to paint those doors, when we paint the hinges, do me a favor, don't paint the hinges. Because sometimes the spring wasn't activated yet, and then later on when I get there for the inspection, or Anthony gets there, or Dean gets there for the inspection, and we got to get an Allen key in there, it's all filled with paint already. And it's hard, it starts to slip off. So make sure you activate the spring before you go ahead and paint, all right? Or just don't paint the hinges. Paint the door, just leave the hinges unpainted. Valves on the oil piping, same thing. Make sure the valves are in the right spot. That's what they're looking for in the oil tank, all right? We already went over that. Piping material, exactly the same as the oil piping on the boilers. Make sure it's the proper material, the proper size, all right? Pipe, if the pipe is corroded or leaking. A lot of times in these oil tank rooms, you'll see a lot of moisture, all right? Especially on the old 6 oil, where there was 6 oil in that tank. There's a lot of moisture because of the heat, because that 6 oil is hot, right? So you see a lot of moisture. They want to make sure that that piping is not corroded. Another thing about the piping and materials, guys, on a fill line, and we see it all over the city, dresser couplings. They'll gig us for the dresser couplings because anything on the oil line that has a rubber gasket, just like a flange and a gasket, they don't want that. They want metal to metal because they say that could deteriorate. The oil will break that down. All right? So dresser couplings are a no-no. If you see that on a job, just bring it to somebody's attention. Let us know about it. I'd rather know about it than have an inspector show us about it. All right? So if you guys see it, it's just real important. Everybody knows what a dresser coupling looks like, right? Everybody knows what a dresser coupling looks like? Okay, so we won't get into it. All right. Exposed wiring. Real simple. If you see any open boxes, exposed wiring, open switches, open outlets in an oil tank room, it's a violation. We can't have open wiring, okay? Also, you guys know the light fixtures that we've been putting recently in the oil tank rooms. They're vapor-proof. They look like a jelly jar. Those are the ones they're looking for now. So if you don't see that type of fixture come, and that's what we want to put in, just, let us know, and we'll get it out to you, all right? Those are the ones we're looking for. Lighting and outlets. We just spoke about that, all right? We want the right lighting. The oil tank room has to be sufficiently lit, too. Someone's got to go in there. They want to be able to look around. Fire protection. Real simple, right? The fire rating. Make sure the oil tank is fire protected and the room is protected. The oil tank itself. This is one that everybody has to keep an eye out for when we detail. Because I'm going to tell you about 90% of the oil tanks that we go to for inspection don't have the label on it. And the label is just a capacity label. You know, the sticker that we always put on, and it tells us what the capacity of the tank is, what the working capacity of the tank is, and what the grade of fuel oil is. It's important. And I'm just so used to it now that I carry them in my car. And I bring them into the inspection because I know they're missing. Or, sometimes they're there and then I bring it back. But it's important. Everybody should be able to see that. If you don't see an oil tank label, either on the door when it's a room or right on the concrete wall when it's a wrap, remember, that's a violation. I got to have an oil tank label on the oil tank. All right? A lot of times guys will call me and they'll say, okay, I got a 5,000-gallon working capacity. 5,000-gallon tank capacity. What's my working capacity? I use 10% as a rule of thumb. So I'll make it 4,500. That's, normally on a 6 oil tank because the drop leg was always a little higher. On a 2 oil tank, you could probably use a 200 or 250 gallon or 300 gallon deduction on your working capacity, like 5%, because we only stay 2 inches below, right? So what they're talking about is, because the drop leg that goes down into the bottom of the tank, that last 2 inches could be 200 gallons of oil, right? So working capacity is, where am I dry? When am I getting to the bottom of that drop leg? All right? Containment. The containment basically is 2 things. All right? They're looking for spill containment outside at the fill box on tanks that are over 660 gallons. So if I have 2 275-gallon tanks together, that equals 550, I don't need containment. I don't need spill containment. I don't need rupture containment in the boiler room or at the tank room. But anything that has a capacity, full capacity of more than 660 gallons, we have to look for spill containment. All right? Except with the fill lines outside, you see where they're in the sidewalk? If it's an existing concrete, they'll accept that. Because they say if it's going to spill, it's just going to spill up into the concrete. It's not going to the ground. All right? But outside, on a wall, over a flower bed, or over a window, or over a window well, it's important that that spill containment is there. At the fill box, it has to be 5-gallon capacity. They're not measuring it. They're not coming in and they're measuring, what a tape measure. As long as they see the box there, they're happy with it. All right? You guys have all seen them, right? Out in Clearview, we'll put them on every job. Most of you guys have seen them with just a hinge cover, or sometimes on the wall. It opens out so that the truck driver can just access the fill port. Anybody not know what it looks like? Okay, great. Containment inside the oil tank room, or where the oil tank is when we wrap it. That's the block wall that has to get painted on the inside, so that if the tank has a leak, the oil is going to come up, and it's going to come up into the containment area, but the containment wall is going to contain the oil. All right, they want to make sure there's proper containment so that the oil doesn't go everywhere. We were talking about holes in the walls. If there's a hole in the floor, but I got a beautiful room, I got walls and everything, but there's a hole in the floor, do I have proper containment? Anybody? Of course not. The oil's going to go right down through the floor. If there's a sump pump in the oil tank room, if there's a drain in the oil tank room, a floor drain, right there in the middle of the oil tank room, do I have containment? Absolutely not. It's going to go right down into the sewer, right? Or it's going to go into the sump pump, and the pump's going to pump it into the sewer. So it's, important to look for. All right, and they want to make sure that the oil tank is supported properly. It has to have saddles on the bottom. You want to make sure it's not going to roll. Okay? They'll accept concrete saddles now. They're looking for steel saddles. On new oil tanks, you'll always see steel saddles. But on existing tanks, you see the old concrete saddles. As long as it's supported properly and it's off the floor, it's acceptable. That's what they're looking for. All right? A lot of times you'll see the oil tank half in the ground or half in the floor and half out. That's considered a buried tank because you can't see the bottom of the tank, and nobody knows if it's leaking or not. It's open to inspection. All right? Those tanks have to get inspected every 5 years to make sure that that tank is not leaking into the ground. All right? All right, oil piping, fill location. Where's the fill normally located? Real simple. Outside, right? The truck driver has to get to it. It's either on a wall, at the curb, all right? It's got to be readily available so the guy doesn't have to, come inside a door or anything. It's got to be readily available from the street, that he can see it, all right? You want to make sure it's in the right spot. Again, we talked about over a well, containment, all right? The vent location. It's important, just like Danny's going to talk about the gas venting. It can't be underneath the window, so that when the oil tank is being filled up, people inside the window are going to smell, or in the apartment are going to smell oil. It can't be anywhere near the window. It's got to be 24 inches away. We use 24 inches as a rule of thumb, right? Nowhere underneath, 24 inches left or right. Okay? You could be above a window, as long as there's no windows above it, but you can't be below the window. All right? Also, the vent location, and we saw this yesterday, right? At 1265 Walton, has to be 24 inches above the fill. They can't be level. You can't have the fill and the vent cap at the same height. All right? They want it 24 inches higher. Oil piping material, same thing. We went over that. Make sure it's the proper material. It's not cast iron. All right? It's black malleable. Oil piping supports and pitch. Why do we say pitch? What's the most important thing on a vent line? Pitch. Does everybody understand that? And why? It's going to what? I'm sorry? I know. What'd you say? Say that again? You had it.
If it's pitched the wrong way,
Right.
it went down, stays there.
Very good. The vent has to have a constant pitch upward towards the vent cap from the tank. If it has a sag, or if it goes down, what's going to happen is you're causing a trap. Okay? If it fills up with water for moisture, or if it fills up with oil, you're going to cause a trap, and then the tank cannot properly vent. Okay? We've seen on certain jobs, nothing that we ever done, but a blocked vent. You know what happens to a tank with a blocked vent, and a guy starts pumping oil into that tank with 100 pounds of pressure? Tank explodes. Because the air cannot come out. It's just like a straw, right? Or anything else. If you're going to put something into it, you have to be able to, you take an empty jar and you want to put water into it. The air has to be able to come out so that the water can replace that air, right? Just like oil. In order to put that oil into the tank, the air that's in that tank has to be able to come out. If the air can't come out, you're not getting that oil in. And that tank is just going to explode. Okay? Very, very important. Extremely important that the vent is properly pitched. The other thing is, if the oil does get into it, it's going to drain right back down into the tank by gravity. Okay? So it's got to be properly pitched. The oil lines, the fill lines, sometimes we can't pitch the oil line from the fill downstream to the tank so that the oil constantly flows through, right? Sometimes we have to break down. They will accept that. But they'll only accept that if you put a valve and a check valve to hold the oil in that trap back from coming back to the fill. Okay, so you will see us break down with the fill line, but we have to have the valve and the check valve on it. All right? The level alarm. You have two types of alarms, right? You got a vent alarm, which goes right at the top of the tank, and all that is a little diaphragm in there. And as the air comes through, it causes a whistle sound. And that's for the truck driver to know when the tank is full or not. Because remember, he's not looking at the petrometer. He's not looking at the tank. He's out in the street. Something has to tell him stop. Okay, and he's listening for that whistle. And you'll hear it as a truck fills up an oil tank. It's just a short whistle. I mean, you know, it's a steady, constant, but a slight whistle. Once that whistle stops, that means there's no more air coming out. That means the tank is full. All right, and he's going to shut it off. So there's got to be some kind of alarm. A lot of times you'll see on a lot of our jobs where we do not only a vent alarm, but also a fill alarm. It's an electronic probe that sits on the top of the tank. And then there's an alarm outside. That probe, when the oil level gets to that probe, it's going to ring outside to let the truck driver know. It's like a secondary device, all right? Vent alarm is required. Vent alarm is required. The other thing is very important is the vent has to be within sight of that fill box. Okay? Not only does it have to be outside, but it also has to be within sight of that fill box. So if the guy's standing at the fill or at the truck, he has to be able to see that. Not only hear it, but see it. The oil comes out, he's got to be able to see it coming out. All right? Very, very important. Shut-off valves. Self-explanatory. Right? On the oil piping, we have shut-off valves in the right spot. We have them at the suction lines. We have them on the suction line at the tank. We have it at the strainer. Petcocks we talked about, right? On the pressure gauges. What are we doing now before we leave boiler rooms? We're closing the petcocks. Very, very important. I have been seeing them, guys. I'm so grateful that when I'm walking into jobs now and I look at petcocks closed, I said, wow, somebody heard it. Because we go over it all the time. It's important. For you guys that weren't here the last time, those pressure gauges, you got 150 pounds of pressure oil on them. Close the petcock. We only open them when the serviceman is there. Because if that stays open and something goes wrong with that gauge, it's a fountain of oil in the boiler room and all over the basement. And now it's a big mess that nobody wants to have to clean up. So just closing that petcock before we leave the boiler room is very important. Everybody should be able to see that. Okay? So if anybody sees a petcock open on the gauges by the burner, just close the petcock before you leave. Okay? Where were we? Shut-off valves. Containers, vertical and horizontal. That's just the oil piping when it goes horizontal, that it's going to, the oil, we were talking about the oil getting trapped and stuff. Alarm and containment. A lot of times you'll see when we put the alarm at the spill containment, right? They're looking if all it is a bell that sits down on the floor. If the oil is going to leak, you're going to see the little alarm there, and it's going to ring outside. It's just telling them that there's a spill or ring at the control. The pump is interlocked. Extremely important, guys, on the conversions now. We're going into jobs and we'll take 6 oil to 2 oil conversion. Everybody thinks, oh, great, we'll clean out the tank, take all the 6 oil out, we drop the preheater, take out the electric preheater, put 2 oil in the tank, firing 2 oil. Sometimes we've got to clean out the gas can because all that 6 oil got in the gas can. And then we walk away and we got done. Everything's perfect until the inspector comes in. On the 6 oil jobs, the oil pump runs all the time. Right? 2 oil and 4 oil it can't. 2 oil, they want it to shut off with the burner. So it's one thing that we always constantly forget. And I'm partly to blame because I forget it too. We have to interlock the burner with the oil pump, or the oil pump with the burner. Only when the burner's on should that oil pump run. Okay? For you guys, the electricians, real simple. The 6 oil line has a temperature gauge on it, right? Which turns the pump on and off. All we have to do is take those same 2 wires, put them on a relay, interlock it to the burner. Okay? It's a simple fix. It's just adding a relay. All right? So if you see on a 2 oil job that the pump doesn't shut off and it's running constantly, inspector's going to pick that up. We just got to add a relay. All right? And last but not least, anti-siphon valve. Everybody knows what the anti-siphon valve looks like? Sits on the suction line. Where does it go on the suction line? Right over what? I'm sorry, what was that? The arrow towards the boiler, that's good. Where does it go on the line, though? Where? Highest point. The highest point of that oil line. Okay, so if we come out of the tank, we put our anti-siphon valve, and then we go across 30 feet, and then we break up, because the boiler room's on the next level, or the boiler's higher than that. It's got to go highest point. Trick question, though. The pump is higher than the tank. Do I need an anti-siphon valve? No, why not? I can't siphon higher than the pump than the tank. Okay? I can only siphon at a lower level.